Hi there. If we are lining up some objects, such as these three creatures here, the dog, the flamingo, and the chicken, the way we can work this is we can actually calculate the number of ways and the order that we can line these guys up. So we have the three places, so we could have, as we have it there, dog followed by chicken, followed by flamingo, or we could have dog, flamingo, chicken. Actually, that's what's there, isn't it? Or the first place can actually go to the flamingo, dog, chicken, flamingo, chicken, dog. Otherwise, first place can go to chicken, dog, flamingo, chicken, flamingo, dog. So if we actually did this in another logical way, we can present it as a tree for the three places. So the first place has three options, dog, flamingo, or chicken. If dog is chosen on the first option, then the other two options for second place is flamingo and chicken, and for third place has to be chicken here, and if chicken was chosen for second place, has to be flamingo there. So that allows us then to do our lineups in the same way. So the first one there was dog, flamingo, chicken in that order, dog, chicken, flamingo, and so on. So what we have here for second place is we have a multiplication principle going on, so that first place is three possibilities, and then it's multiplied by two possibilities for each of the second two places and one possibility for the third. So we actually write that 3 to 1 can be written as 3 factorial, and that factorial sign there, that exclamation mark, just means that it expands out to that 3 by 2 by 1. So that means that there are actually 6 ways that we can arrange these creatures. So I challenge you just to kind of grab some little toys out and have a play around, or write them down and finish off this example. Similarly, if we want to line 5 creatures up and decide on a line-up order, we can use the multiplication principle again. First place, there are 5 options. Second place, there's the remaining 4 to choose from, multiplied by 3, by 2, by 1. So those are the places. Sometimes I underline them like that. That can be expressed as 5 factorial, which is that guy there, 5 by 4 by 3 by 2 by 1. Now you can calculate that out in your calculator, or you can actually punch this straight into your calculator, and your calculator does the work for you. In your scientific calculators and your Texas Instruments, what you need to do is you go to this third button down here, this math key, and then you get these options here along the menu. So you want probability. Once you hit probability, you can come down on 4 there. So you could easily put in something like 5, and then I was choosing the wrong thing there, 5, and then hit this key here, and then it will give you the calculation for you. So those were straight lines, and the next way that we can line up objects is in a circle. So let's say that you are sitting down with 3 of your friends here. So this is you here. The problem with trying to work out the lineups is, in fact, that you can actually end up on the other side of the table, and yeah, that's it there. So on the other side of the table, and being in a circle, it can just kind of be like a, you could end up here with a dog on your left and the flamingo on your right. So you're just kind of rotating around the table. So what we do with circle lineups is we fix you in place here, so you don't move. So one of the objects is actually fixed, and then we can move around the other 3 objects relative to that object there. So in this case here, we can move the puppy and the flamingo and everyone around the table. We can switch them all around. They don't want to move for me at the moment. And so for 4 items that are being arranged in a circle, what we actually do is, because we fix one, we end up having 4 minus that 1 factorialized. So it's actually the 3 that we're switching around, whilst you stay fixed in one place around that circle, just so we don't get those rotations. So there are n objects minus 1 fixed place factorial. That is for circles, okay? So that's the number of ways you can line up or arrange items in a circle, as opposed to a lineup, which was n factorial, n being the total number that we are doing. Now, another situation you might have is you have some of the items need to stay in a block. So, for example, if the three birds kind of want to hang out together and be a bit of a pack there, and must sit next to each other when we line them up in the spaces, we can consider that we have actually three spaces. So this one here, we can just call it the birds. We've got the cat, the bird, and the dog. So we can just arrange them in the order here. So what we actually end up having is a 3 factorial, where the birds might go into one of these 3 positions at any time. If the birds came here in second place, then we would have flamingo, what's this guy called, toucan, and chicken. Now, the other thing that happens is we can actually rearrange these creatures within their lineup. So what we have to now consider is that instead of having flamingo, toucan, and chicken, we just jiggy them around in their own order. So the possibilities there now are flamingo, chicken, toucan, or that one, or chicken, toucan, flamingo, and so on. So within each of those 3 spaces, the little blocked group of birds can actually also be rotated 3 places within themselves. Okay, so this one here is the number of places that we've got once we consider the items as a block, and this one here, the blue times 3 that we've put in our calculation, is the number of ways that that block can be considered to be rotated within itself. I'll do another example next, just because the 3 and the 3 are the same number. Okay, for another example, if we have 7 students and they're lining up to have their photos taken, we have 7 spots in our tree, so it's a 7 factorial. However, if we had 2 twins amongst them, and they needed to be standing next to each other in the photo, we treat them as a group and we reserve 6 spaces now. So the twins will stand as a group. So we have 6 factorial places where the twins are considered in a block. But then we're multiplying it by the permutations or the arrangements that we can have of those 2 twins. Because there's 2 of them, there's 2 ways we can rotate them, okay? So we can have Arthur and Martha in that order, or Martha and Arthur. So that's the 2 different ways that we can rotate them. So there our formula becomes 6 places, and then the 2 twins here are also an arrangement within their place. So we multiply that together. In the next situation, we can have identical items. So in your textbook, they do this with words quite often. So they will say to you, look, how many ways can you arrange the letters in parallel? And of course, the 3 L's that are in it, doesn't matter what order they're put in, because those double ups kind of don't really change some of the arrangements or some of those ways, because they're exactly the same. So in a very simplistic example here, like our birds, what we actually do is we have 1, 2, 3, 4, 5 places. So it's a 5 factorial. All right. But then we divide that by the number of ways that we can arrange the 2 items, okay? So it becomes a divide, 5 factorial divided by 2 factorial in this case, because we don't care if one of the toucans is in place of the other one. So we're actually going to divide it by the number of items as they arrange, left, right, as these 2 guys kind of arrange within those 5 places. So the way that I'm just going to show you a little trick here with our factorial. If I expand the top line out, and then I'm dividing it by a 2 factorial, then I can just cancel down, because I can cancel down fractions that are multiplied like that to a 5 by 4 by 3. 5 4s are 20, 2 3s are 6, 60. is the answer. So we can have 60 ways that we can arrange those guys, and we don't notice if the toucans are in sort of how they appear. So it becomes like a reduction, a reduced. Otherwise it would have been 120 just for straight up 5 factorial. Okay, and just finally, this concept leads us off to the next ones that we're moving towards. If we have, so far we've just talked about all the items being lined up, so all of the objects get used up in the arrangement, and so we tend to call those ones arrangements. So I'll just note that up here, because we're arranging all items. But if we're selecting, we have like a shortened or truncated arrangement set up. So an example of this is we have 5 students here, and we are choosing 3 places. So they might be involved in a race, and the first possibility or the first place could be any one of those 5 guys. So it's a 5 by 4 by 3 arrangement, and so we stop there. So 2 of them will not be involved in the lineup. So what we're actually doing here is we are picking from 5, 3. So that's a notation there that we use, and we say 5, pick 3. Now this here is a selection idea rather than arranging all. Okay, so it's a reduced situation. Now the mathematics for this, oh, that was interesting. The mathematics for this, we can write like this. We can actually write it as a division, and I'll show you why. So in our 5 factorial, we write it like this. Upstairs we write 5 factorial, and if I had 5 by 4 by 3 by 2 by 1, that's my 5 factorial, and I'm actually cutting out the last 2 places. So that would be the same as dividing it by 2 factorial. So when we have something that's not a full factorial, so a full factorial with the exclamation mark means it goes right the way down to times 1. With a partial factorial, we write it as a division so we can get those numbers right. And what we're actually doing is we are taking the number of objects that we have in total, and we are dividing it by the one that we don't pick. All right, so the total number is 5. The one we pick is R, and the number that we don't pick is 2. So the 2 comes from n minus r, factorialize that. So there, that equation there is just 5 by 4 by 3. It looks a little bit more complicated than it needs to, but that's all that we're doing. We're actually reducing the lineup by 2 places shy of the full factorial, just by 3 places. So it's a 5 by 4 by 3. So let me just finish off expanding that out for you. That would become 5 factorial divided by 5, take 3 that were chosen, factorial, which is 5 factorial divided by 2 factorial, which actually just ends up being boom, 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 cancel, cancel, 5 by 4 by 3. It's a very simple concept, and the mathematics or the equation looks a little bit kind of intimidating, but it's actually not. It's just showing us that we have 3 spaces and we don't arrange all the items. So that leads us on to the next topic, which is permutations and combinations, and they are selection types, as opposed to arrangements, which are all types. Hope you enjoyed that. Bye.